More and more researchers are using satellite-detected nighttime lights to study economic activity. These data cover the populated world, with some sensors having time series data going back to the 1990s. If gross domestic product data are absent, nighttime lights data can greatly expand research opportunities. They can be used to evaluate the effects of natural disasters, public health crises, and monetary shocks. Validation studies often compare nighttime lights data to traditional GDP data for national or provincial units, whereas luminosity is increasingly used to study local development. Validation studies mostly use older, less accurate DMSP data from military satellites, and not the newer, more accurate data available from the Visible Infrared Imaging Radiometer suite. Few validation studies distinguish between cross-sectional uses for comparing places and time series uses where temporal changes in luminosity may reveal the local economic impact of some shock or intervention. We used regressions with multi-source nighttime light data to predict county-level economic activity in China. Over 2,650 counties have annual data for 2012 to 2019. Providing a large sample. China is a good location for this exercise, as few other countries have benchmark GDP data at the county level. China's rapid economic growth and conversion of farmland into cities has driven big changes in luminosity and in GDP, enabling us to precisely estimate the relationships between them. We used 4 types of annual composites of light data. The first is DMSP, the oldest and most popular light dataset in economic studies, which suffers from blurred, top-coded images, a lack of calibration, and low resolution. The second dataset from the VIIRS has a higher spatial resolution and no top-coding problems. We also used 2 types of NASA black marble data, one for snow-free nights and one combining snow-free and snow-covered nights. This was conducted because reflectance differs for snow-covered ground. Combining both snow-free and snow-covered sets provides images from about 180 nights per year with which to form annual composites. In contrast, annual composites for DMSP are extrapolated from just 60 nights per year. Black marble data should therefore give a more reliable picture of annual economic activity. We found that nighttime lights could predict cross-sectional differences very well, explaining well over half the variation in county-level GDP. They performed far worse when predicting changes in economic activity over time, explaining only 1% of the annual fluctuations in county-level GDP. Non-nested model comparison tests showed that models of county-level GDP using black marble ensemble data on snow-free and snow-covered nights as predictors were more representative of the truth than models using other nighttime lights data sources. For countries with snow-covered areas such as China, using radiance measures from these nights, as well as from the more widely used snow-free nights, provides a better indicator of differences in annual economic activity. Nighttime lights data are far worse at predicting temporal changes in economic activity than they are at predicting spatial differences in economic activity. Time series relationships are inelastic, while cross-sectional relationships between GDP and luminosity move almost 1-for-1. Hence, a change in local luminosity over time in response to a particular event, for example, a shock, does not imply a proportionate effect on local economic activity, because the 2 sets of changes are only weakly related.